So is it okay to heat my test sieve? And what happens if I do? Well, look no further. I'll explain everything you need to know about safely heating your test sieves. Stick around. Hi, I'm Candace Blaker, and since particle size analysis is an incredibly precise industry, it is critical that you handle your test sieves with care. This includes the way that sieves are handled when applying maintenance techniques, like applying heat after cleaning. So, how should heat be applied to test sieves, and what should I try and avoid? W.S. Tyler has been a leading test sieve manufacturer for over 110 years, and is here to share the knowledge within our four walls to help you obtain accurate and repeatable results for years to come. With that said, what we'll go over are the reasons why test sieves are heated, how heat can affect your test sieves, how you should safely apply heat to the sieves, and the consequences of improperly applying that heat to your sieves. After conducting a test sieve analysis, you must clean your test sieves to prevent residual sample material from skewing any future tests. To speed up the drying process, lab technicians often place their sieves into an autoclave, which subjects the test sieves to elevated heat. Another way that lab technicians heat their test sieves happens after conducting a wet sieve analysis. The finer material that washes away from the bigger particles must be dried to ensure that it's dry and free-flowing material. This ensures that you can successfully run these particles through a dry sieve analysis later on. Standard test sieves are comprised of three main components. These components are the frame, the skirt, and most importantly, the screening media. Now, in order to successfully mount the screening media to the frame and keep it drum tight, a binding agent must be applied along the crease where the screening media and the frame meet. This is generally either an epoxy or, in special instances, solder. With that being said, when heating your test sieve, the binding that's used, whether it's epoxy or solder, is what is affected when you apply heat. And it should be noted, when working with brass test sieves, applying heat may cause the different brass components to become discolored. But this is only an aesthetic issue and will not affect the performance of the sieve. To ensure your test sieves continue to produce accurate and repeatable results, you must pay attention to the temperature that you apply. The temperature threshold is different based on the binding agent used. For epoxy sieves, temperatures should not exceed 200 degrees Fahrenheit, and for solder-only sieves, temperatures should stay below 450 degrees. You'll want to ensure that you're not overheating your test sieves. Depending on what binding agent is used on your sieve, you can run into one of two after effects, both of which can permanently compromise the effectiveness of your test sieve. If you're working with an epoxied sieve, the main concern is the epoxy becoming brittle and cracky. And if you're working with a soldered test sieve, overheating can cause the solder to soften and in some cases, turn back to a liquid until it's cooled. Regardless of the scenario, when the binding of your test sieve becomes altered or damaged, the screening media will lose its proper tensioning. This, in turn, will cause your sieve to skew your sieve analysis results. Thank you so much for watching. If you have any questions, fill out a Contact Us form so we can answer your specific requests. Just click the link in the description. And if you'd like to learn more about woven wire mesh or our many products, we have a learning center filled with written and video content to make you an expert. Just click the second link and you'll be that expert in no time. And don't forget to hit the subscribe button and ring that bell to keep up with all things W.S. Tyler. Once again, my name is Candace Blaker, and I'll see you around in the next video. Bye for now.